At this point, at least from a data management standpoint, you already know how to perform many different crucial tasks in SAS. You've learned the basic tools necessary to get data into SAS, manipulate it, and enhance its readability. But remember when I said that there's almost always more than one way to carry out any given task in SAS? I also said that usually these alternate ways are no better or worse, just a matter of preference. However, as you will learn in this lesson, some alternate ways of coding, while maybe not better per se, clearly offer some efficiency advantages. Although do loops and arrays are different concepts and can be used independently of each other, you will find that they're often used in conjunction. Because do loops and arrays tend to be a bit confusing for people at first, we're going to start off slowly in this lecture. You've already seen a do statement before. In the conditional processing module, you saw do statements used to form do groups. Another use for a do statement is called a do loop, which is what this lecture will focus on. As you learned in the last module, using do groups in your programs allows you to process multiple SAS statements given a single or multiple condition. Do loops process a SAS statement or group of SAS statements repeatedly rather than once. If you remember nothing else from this video, remember that. Additionally, there are two special cases of do loops called do while and do until loops, which we will also cover today. The basic idea behind do loops is actually pretty simple. You will sometimes find yourself writing code to perform a task or perform some calculation that becomes repetitive. For example, you may find yourself typing the same if-then statement over and over, only changing the variable name each time, as shown here. Do loops can help you reduce the amount of programming you have to do in situations like these by typing the if-then statement once and then telling SAS to repeat it as many times as you specify. The best way to understand iterative processing is probably with an example. This demonstration is intended to introduce you to the basic concept of iterative processing and how do loops work. Let's start out with simple example number 1. Here we are creating a temporary SAS dataset called Simple1. Then we have what's called a do group. It begins with the keyword do and always ends with the keyword end. The keyword do is followed by the index variable I. Note that the index variable does not have to be I. However, for some reason it commonly is. The index variable is sometimes referred to as the counter. Then there's an equal sign, a starting value, in this case 1, and an ending value, in this case 4. The next line is a SAS statement where we are telling SAS to create a variable called answer that is equal to 1 plus I. The idea here is that we are telling SAS to set the value of I to 1, then execute the statement below, then loop back and set the value of I to 2, and execute the statement below again, and so on through I equals 4. Let's run it and see what happens. So here we see that we have a value of 5 for I and a value of 5 for answer. Not quite what you expected, right? Here's what happened in SAS's mind. At the top of the data step, SAS creates a temporary data set called Simple1. Next, the counter I is set to 1. The SAS statement answer equals 1 plus I, or in this case 1 plus 1, is executed, and the value for answer is filled in. In this iteration, answer equals 2. When SAS encounters the end statement, the value of I increases, or is incremented, by a value of 1, and SAS loops back to the beginning of the do statement. The do loop continues until I takes on a value outside the range provided in the do statement, in this case 4. So in the fifth iteration, SAS recognizes that I equals 5, which is outside the range you provided, and exits the loop without executing the statement again, leaving the value of answer at 5. By default, SAS automatically outputs the results of a data step from the PDV to a SAS dataset once it reaches the end of the data step. In this case, SAS automatically outputs the value of I and answer at the end of the data step, so 5 and 5. But what if you want to see the results of every iteration of the do loop, not just the final iteration? This demonstration will show you how to do just that. If we want SAS to output each step in the do loop, we have to add an output statement to our code. The output statement is an instruction for SAS to write out an observation to the output dataset. As I said, an output usually occurs automatically at the bottom of the data step, but here
we want to output an observation each time we compute a value of answer. It's important to note that when you include an output statement anywhere in the data step, SAS does not execute an automatic output at the bottom of the data step. Let's see what happens now. And here we see the value of answer at each iteration in the do loop.
Now that you've seen an example, here's the general form of a simple iterative do loop. It begins with the keyword do. Next, the index variable stores the value of the current iteration of the do loop. The naming rules for index variables are the same as other SAS variables. However, I and j are commonly used. The start value specifies the initial value of the index variable. The to clause tells SAS that there will be a stop value. The stop value is the last index value that executes the do loop. The optional by clause specifies an increment value for the index variable. So far we've used the default value, which is 1. Then you have a SAS statement, or a group of SAS statements, to be repeatedly executed. And finally, all do loops conclude with an end statement. Now that you have a little better idea of what a do loop is, and the basics of how it functions, let's gradually make things a little more complicated, but also a little more useful.
For starters, the index variable is necessary for the loop to operate, and may sometimes be of interest in and of itself, but most of the time we don't care about it, and don't want to retain it in our data set. In order to get rid of it, we add a drop statement to the first line of the data step, like this. Next, although the default increment of change is 1, we can control this in a couple of different ways. The easiest way is to use a by statement. In this example, we've changed our start value to 0 and our end value to 10, and we've used a by statement to tell SAS to increase I by increments of 2. Similarly, we can use a by statement to incrementally increase by non-integer amounts. Here we are telling SAS to increment each loop by 0.25. And what if we want to decrement or count backwards instead? Well, we can do that too. In this example, we are decrementing from 10 to 1 by 1s. All we have to do is use a negative number in the by statement. And finally, we can explicitly list the values which we want the do loop to execute over, like this. We can also place a do loop inside of another do loop. These are called nested do loops. In this example, we are using nested do loops to generate integer values between 1 and 10 inclusive, and their squared values.
Sometimes you don't know the number of iterations you want the do loop to execute over. In these cases, you can use do while and do until loops. The loops execute until some condition that you've defined is true in the case of do until, or false in the case of do while. Here's a do while loop. You tell SAS to iteratively run the SAS statement answer plus 1 while the value of answer remains less than 11. As a side note, the SAS statement here, answer plus 1, is a specific type of SAS statement called a sum statement. There are two primary uses for a sum statement. One is to accumulate running totals, for example, a running total of an account balance with interest. The other is to create a counter. This application of a sum statement can be particularly useful when managing longitudinal data sets. The general form of the sum statement is variable plus increment. Notice that there's a plus sign, but no equal sign in a sum statement. That's what identifies this as a sum statement to SAS. Now, let's see do while and do until loops in action.
Here is a do while loop. We tell SAS to iteratively run the SAS statement answer plus 1 while the value of answer remains less than 11. You can see that the answer increases incrementally by 1, but why does it go to 11? Well, we have to remember how SAS thinks. The do-while condition is tested at the top of the loop rather than the bottom. So, when the value of answer is equal to 10, SAS went back to the first line of the do loop and evaluated the condition. 10 is less than 11, so it executed the sum statement answer plus 1, which is 11. It then went back to the top of the loop and evaluated the condition again. This time it wasn't true. 11 is not less than 11, so SAS exits the loop and moves on to the next part of the data step. The code below is a do until loop. Unlike the do while loop, the do until loop tests the condition at the bottom of the loop. Otherwise, it's very similar. Here, we are telling SAS to execute the sum statement until the value of answer is greater than 9.
And that's a brief introduction to do loops. Granted, these are silly examples that don't seem very applicable yet, but do loops are confusing for many students, and these examples demonstrate in a very simple way how do loops work. I encourage you to Google more about do loops and play around with numbers, variables, and options. Once you master do loops, they can drastically increase your coding efficiency.